Hey, I have another question that you can add. Hey, cool.
We're making a keynote.
I have another question you can add at the end. Ask why the XBee is shaped the way it is.
She's writing it down.
Okay. Someone might care. People ask me, and I never knew until I asked. It's not particularly interesting, but at least they'll have the answer.
I like that. That's a great question. Are you going to share about what the original shape of the XBee and the original coloring of the XBee?
Color?
Wasn't it black with like yellow stripes?
That was just a prototype.
Yeah, that would be great. Hey, how are you going to ask us these questions?
I'm going to have people either chat them in or like tweet them. Or I'll tweet them to you guys.
Great.
If you want, you could sit on the couch, and I can turn the air conditioner off so it's not going to be over there.
That would be good.
All right, let's sit.
Ooh, got the skill badge.
You have a badge?
You've never seen the skill badges before?
No, what is that?
How is that possible?
Yeah, that's amazing. I don't.
Is it a merit badge?
Yeah, it's an XBee merit badge.
No, there's not an XBee merit badge. Dude, I'm an Eagle Scout.
Hold on, I'm going to send you that link.
It's not a merit badge, but it's a skill badge. It's like a merit badge.
Skill badges for what?
Everything you guys are saying is being on there.
Oh, I know.
Okay.
Yeah, this is being broadcast live. Liz wants everyone to know. The live link on the blog. So I'm going to chat this out to you. Adafruit makes these wonderful.
That's exciting.
Your laptop up.
Back it up. I'm like in my face, huh?
Yeah. You look like the floating head of XBee.
Yeah.
That's good.
Yeah.
You want to be close enough.
Mm.
Have you ever considered having the sides of your head just like tilted in a little like that?
Yeah. I've shaped my hair that way one time.
Nice.
We have 2 minutes.
Yeah.
No one's here. That's okay. Usually it's just like meetings in the real world where people generally show up like 5 minutes late. Everyone's got stuff to do.
Right. And what will happen is everyone gets to watch it afterwards still.
It might just be the 3 of us and Quinn.
Quinn.
Now, can you tell if people are watching this live?
Yep.
On the live feed?
Yep. Anyone who comes in the Hangout will show it's just like that.
Even the people when you post it on the blog?
No, not those people.
We don't know if they're watching or no.
Nope, we don't.
Exciting.
I'm next door to Quinn, so if anything goes wrong, he might come over here.
Oh, that's a different Quinn.
Oh.
Our Quinn is 11.
Disregard.
Where are you sitting right now? Where is that?
The corner office.
Ah, you should just. It's a book that I have that suggests if you want the corner office, you should claim that you have a cold, and that's where the draft stops. And then once you get over your cold, you just never move out. Let me adjust my shirt.
You do that anchor thing?
Yeah. Represent.
Oh,
I'm representing my school.
Brigham Young. Oh, I didn't know it was the Cougars.
Yeah.
Now I know. I had.
Has that gotten awkward since the meaning of the word changed? Oh, we're live.
No. Yeah. Okay. Great.
I did bet on BYU during March Madness and got sadly disappointed.
Or you can see viewers.
Ah, that's great.
Okay, let's give it 2 minutes and then we'll go ahead and get started.
Sounds great. 2 minutes and then we'll get underway.
All right.
XBee time. This will just be informal XBee pivoting with Jared, Jordan, and Rob.
I told Liz this was the first time I've ever used a webcam.
Really? Well, I mean, that doesn't surprise me, considering that most of the wireless things that you deal with have a very low symbol rate. Probably can't connect the webcam very easily. Although we do have a lot of cameras connected to extends and Ethernet bridges. Right?
We make webcams.
Oh, well, certainly we make webcams, but not a lot of them go over XBee.
All right. No, well, no, not in Jared's world.
I'm still waiting for the era of, people that are connecting imagery, analyzing and imagery taking devices to XBee. I don't really see that very often.
Coming soon.
Yeah. Microphones. We had the people that were doing occupancy with microphones.
Mm-hmm.
Okay, we have 6 viewers. Let's go ahead and get started.
That's great. Well, welcome.
Hi, everybody. I'm going to give you a little bit of some background on what we're going to do today. I'm going to introduce you to the people who are going to be talking about the XBee and also give you a little bit of information on the format. I'm Liz Cresson. I'm the social media manager for Digi International, and also talk to you on Twitter if you follow XBee there as XBee Wireless. I'm going to introduce you to our team here. We have Rob Faludi, who is the collaborative strategy leader for Digi International. He also wrote the book, Building Wireless Sensor Networks, so you could know him from that as well. We have Jordan Husney, who is the iDigi Device Cloud product manager and the author of the article we've been talking a lot about, the XBee Garage Door article in Make Magazine. And then we have Jared Hoffins here as well, who is the XBee product manager, so he has some great insight. And he's actually going to get started by telling us a little bit about the history of the XBee.
All right. Thanks, Liz. So in order to understand the history of the XBee, first we need to know the history of MaxStream. So MaxStream is a company that Digi acquired in 2006. So 6 years this month, actually. And that company was started back in 1999, started with a little RF module called the 9Xtreme. And the idea that MaxStream really wanted to put out there, or the product they really wanted to put out there, was a really simple, easy-to-use RF module. At the time, in order to send data from one side to the other, you had to understand the frequency hopping algorithms, had to control all those kind of things. So MaxStream said, you know what, if we could just do the frequency hopping automatically, it would be so much easier for people. Also, why don't we do the addressing automatically for people? So whatever you send in one side of one radio goes over the air, comes out the other side of the radio. So great. They saw a lot of success with that. I joined the team in 2003. Around 2004, we were realizing that there's quite a bit more potential, quite a bit more space in the marketplace to win more designs. Particularly, the price point on the 9Xtreme was in that about $150, maybe $50 to $150. But we thought if we could get things under $50, these will really start to take off and sell well. So at the same time, there was an emerging standard, the IEEE 802.15.4, being led by XBee in order to do mesh networking, but the 802.15.4 just did point-to-point and point-to-multipoint. So we had this idea. We wanted something smaller. We wanted something along that new standard and something really easy to use. And the idea came up that we do this XBee. And one of the guys on the team had done a Bluetooth radio at a previous company, and it was about postage stamp size. And he said, "Why don't we do something like this and do 20 pins, 10 pins on each side? Is that going to be enough?" And so anyway, just ideas floated around, and that's when the XBee was born. 2005 was the first model that came out. It was just called the XBee. We didn't know there was going to be other series. We didn't know there was going to be all these different frequencies. So it's just called the XBee. Later, we came out with the XBee version of that. So the first XBee became XBee Series 1, and it just did 802.15.4 point-to-point, point-to-multipoint. And then the Series 2 was the XBee side. Another thing we had done was that we had put in a couple of repeaters, and we knew that mesh was taking off, although multipoint was still really important. So we also knew, remember, the 9 Extreme was at 900 megahertz, 100 milliwatt type of radio. So we knew the power or the marketability of that 900 megahertz spectrum. So we thought, what if we take this XBee and make a whole family out of it, have different frequencies, different regions of the world, different protocols. And so from that, we've just kind of added on, and we've even got Wi-Fi now. We've got DigiMesh, our own mesh standard, and it turns out that still the most popular, most sold today, the XBee Series 1 or the XBee 802.15.4, just standard point-to-point, point-to-multipoint kind of radio, really simple, easy to use, and simple has staying power. So back to you.
Great, thank you, Jared. Also, I wanted to mention that if anyone is watching the live stream on the blog and has questions, you can tweet us at XBee Wireless, and you can use the hashtag XBee Forum. So you can send your questions in via Twitter as well. I'm going to now pass it on to Rob and Jordan, who are going to tell us a little bit about the XBee capabilities, talk about some projects, and then answer some of your questions.
Great, thank you very much, Liz.
So I'll get started, I guess. And Jordan and I really look at the XBee radio a little bit from two different perspectives, because there's two different ways of looking at the XBee radio, maybe a lot more than that. But the way I think of the XBee radio is as a really useful tool for people who I call innovators, and those might be scientists or artists or product designers or students or academics who are interested in making a wireless device of some sort. So in other words, a device that's maybe it's going to be spinning, maybe it's going to be mobile, maybe it's just in a situation where wires aren't an appropriate way of it communicating, or maybe they want to connect it to the internet. And the XBee radio makes it really easy for people who want to move relatively small amounts of data back and forth from a device they prototype themselves to either the internet or maybe another computer or maybe another device. Jordan's world, if you will, and they're not really so, they're not really walled off from each other, is more about the uses of the XBee radio in industrial formats. So a company that wants to put a whole sensor network in, maybe for maybe you want to monitor hotel rooms, or maybe you have an exercise facility and you want all the machines to report in data, or maybe you have a bunch of diesel tanks that are off in Alaska and in remote areas, and you want to know how full they are, or a variety of other things. So actually, I'll let Jordan talk a little about the industrial uses. That's most of the uses of the XBee radio. But then most of the ones I think that consumers hear about are the ones from the maker community. So let's learn a little about just industrially what they're good for.
Yeah, absolutely. There's a lot of industrial and commercial uses of the XBee radio, some really creative applications. A lot of the applications that we see end up being a company's secret sauce. So you don't hear a lot about it. The little XBee radio, we have a few right here. This ends up actually being embedded in a lot of products that businesses buy, and they kind of keep it to themselves. One such application that we've seen had to do actually with water treatment plants. So this company makes these water treatment plants that get co-located on the site of industry or within cities. And previously what they were doing is they were actually sending out human beings to all of these different plants. And those human beings had really big dipsticks. And what they would do is they would actually dip the sticks in these tanks of water treatment chemicals. And then they would make a little notation in a notebook. And then they would email that to somebody, and then that information would get ingested in a database, and then they would route the chemical truck to go and fill up all of those tanks. Well, they came in contact with Digi, and what Digi did is they worked together. We worked together with a partner who actually put one of these in a very simple chemical tank level sensor, basically a little pod that actually beams a signal down. It actually looks quite a bit like this little thing here. And what it does is it actually sends a little acoustical signal down the tank and gets a return, much like a bat can see its surroundings, and then sends that data through an XBee to a centralized gateway, and then that gateway sends it up to the company's database using the iDigi platform. And it revolutionized their business. It changed it from a business wrought with people spending a lot of gasoline going out to these remote sites. Sometimes, and actually they had to cross a desert in order to find some of these water treatment plants, to being able to actually automate all of that and do it without error. And we see these kinds of applications, these business-changing applications for people that are not entirely difficult to accomplish now with the technology that we have, but they're quite sophisticated. And we believe that the reason for that is that the XBee makes it really, really easy, and people can get started, and they can experiment very simply in a laboratory environment and spread it all over their business.
Right, that's right. Another very popular use industrially for XBees is in electrical monitoring, and so as part of the smart grid. In fact, before working for Digi, I worked for a company called Grounded Power, and our job was to find a way of getting information about electrical consumption in the home, bringing it to people, showing it to them, but really for the purpose of changing their behavior. So we took this information, so we used current transformer clamps to get electrical information, figure out how much wattage the house was actually using, and then display that to people. But it was really part of a larger information system that got them to understand, got them to make a goal on how much energy to save, taught them different ways of saving energy, and then gave them feedback and also social feedback about how much they were using and how to use that compared to other people. And this is typical with data, is that you don't only just want to get numbers, but you want to transform that into meaning. And so I see the XBee radio, we like calling them up, or groups of XBee radios, as being that first step in getting information and transforming that into meaningful data and meaningful experiences. So that's kind of the big picture from my view. Now, of course, a lot of people do really interesting things with the XBees that are not so cut and dried. There are people who make clothing that lights up. There's people making what I think of as performance or show control tools where movements of the body are being transmitted for the purpose of controlling video or audio. There are people doing whimsical things like monitoring their the amount of noise at different locations in their office and transmitting that online so that you can monitor a Twitter feed and find out where the action in your office is. There's someone experimenting with a sheep herding robot. There are famously the Esper dominoes, or dominoes that are wireless, and as each toy domino falls over, another one will be triggered to fall over as well, but they never touch each other. So the only limit really is imagination. We see new projects every day. In fact, if you go take a look at gallery.digi.com, you will see a variety of really interesting creative projects that are being done with the XBee radio.
And what's fun to see is first of all, the number of people that are experimenting, trying things, some which are more whimsical, some that have some very practical applications, and some that just take off like a rocket. If you were talking about energy monitoring, I remember when I read first about the tweet a lot, which was Lamore Freed's concept of actually hacking a current monitor, plugging it into the wall, and then making it social. And then we see that same pattern, and we see really the same basic bits of technology at work that are the foundations of lots of startup companies in industry today.
Sure, absolutely. And in fact, the way that this information is made social, so you got your XBee radio, and that's sitting inside some device and transmitting information using the 802.15.4 protocol, or possibly the Zigbee protocol that's layered on top of that, so that two XBees or three XBees can talk through each other to get to a third location. And things like gateway. So this is a Connect port gateway. Let's get it lined up properly here and see what it looks like. It's fairly small, fits in my hand. And inside the Connect port gateway, and I'll actually go ahead and open this up. I'll grab a screwdriver, is an XBee radio and basically a little computer inside with Ethernet plugged into it, so that you can take the information from your XBee network and gather it all up in your home or in your business and put that online. Digi makes these that connect to Ethernet, but we also can connect through cell phone systems. We even have ones that will link up to a satellite, so you can do it from anywhere in the world. I'll just grab a screwdriver so I can open this up.
Please. Well, Rob's doing that. One of the most common sets of questions that we get, we kind of see this cycle of evolution as people kind of discover what they can do with wireless things. Really, sort of the first thing that we see is people kind of want to connect two things. So they decide, all right, I want to make it so that I can tell when somebody's in the bathroom, right? That's actually an application that I saw in a studio once. People wanted sort of an in-use light for the bathroom. So they decided to connect a light up to one XBee, and then they decided to connect a door sensor up to another XBee. We see that sort of thing happen first. And then invariably people say, wow, I wish I could actually transmit that information so I could get it on my mobile phone or on a web browser or something. And so they want to go over the borders, and they actually want to transmit it through a gateway. And that's really what the gateways are all about.
Right. So this gateway, which I showed you before, is a box which, if we open it up, really just has two things inside that are important. So let's get that close enough. So you can see there's an XBee radio inside, and then there's also this Ethernet module, the Connect ME, and the rest of the circuitry in this board pretty much just ties this and that together. The Connect ME is special because it's not just an Ethernet plug. It'll also run Python, and Python is a kind of easy-to-use programming language where you can tell this module what to do when things come in from the XBee, and also what to do if something comes in from the internet, which XBee does maybe send it back to. And by writing some code in here, you can organize a whole really interesting application that might run in your home or on-site at your business. But that's all there is to that. So even the bigger Connect ports with more features are just really going to have more different connections. So they might have essentially what's a cell phone or serial or a satellite modem in them as well. But I find this one the most fun and useful, and it starts off around $100 for one of these, so way cheaper than having a computer doing the same thing.
Yeah, of course. You don't actually have to write Python code in order to get the information from the XBee across the internet. We have a project that, well, I think Rob actually started when he was a professor at NYU called the XBee Internet Gateway, and then kind of took off as an open source project And well, why don't you explain what the XBee Internet Gateway does?
So in really simple terms, the XBee Internet Gateway is a piece of software that is used to connect any XBee really easily to the internet. So if you have an XBee, I always like to hold up an XBee when I'm talking about it. It calms me.
Yeah.
If you have an XBee and you want to put it online, we wanted to make it as easy as possible to do that. So many of these are used in the maker community, and they're sold. Well, we at Digi sell them directly. You can buy them on places like SparkFun Electronics sells them. Adafruit, another maker resource, sells them. The Maker Shed of Make Magazine sells them. And then we have larger distributors as well, places like DigiKey and Mouser, where you can buy them. But we wanted it to be really easy to grab some information from this and just stick it right online with the least setup possible. And so I started off by prototyping an application that runs on the Connect port. So it runs right in this little module. It basically says, anytime an XBee, a remote XBee, sends some information to you, if that has a URL in it or some sensor information, go ahead and if it's a URL, go look that URL up and send the information that's returned back to this XBee. So this XBee doesn't have to know anything about how to look up URLs, doesn't have to know anything about the internet, it doesn't have to understand SSL or usernames and passwords or anything like that. It can just send some text out to this and get an intelligent response back. Or grab some sensor information and push it to this and not have to worry about where that goes to or how to post it to a database or anything like that. So the XBee Internet Gateway has actually gone through a bunch of revisions to make it more robust, give it more features, and we can actually pass information back and forth really easily to it now, both from the internet at large, any web application you write, or from the iDigi device cloud, which is Digi's solution for gathering up devices out on the internet, taking all their information, and giving a pathway where it can be seen centrally. And iDigi access, by the way, is totally free for the first 5 gateways. So for someone who's maybe working on projects on their own, it would be totally free pretty much forever because you wouldn't need 5 gateways. You can have as many XBee radios as you want connected to each gateway, by the way. So that's, in a nutshell, the XBee Internet Gateway. It's been around for a few years. It's gone through some revisions and upgrading, lots of interesting new features on it. And the one thing that we wanted to do was we still needed to have a Connect port. And sometimes that's a stumbling block for people. So we actually are just right now beta testing a new version of the XBee Internet Gateway that instead of running on a Connect port, also can run on your computer. So if you have a Macintosh or a Windows machine or a Linux box, you can run the XBee Internet Gateway on that, and that will serve as a pathway to connect your XBee to the rest of the internet, lickety-split. So if you're interested in beta testing that, that's something available now, and probably within a few weeks we're going to come out with an official 1.0 release that anyone can download.
Right, and remember, you heard it here first. Actually, this is the first announcement that we're making of that particular project, and we've been working on it for with some other developers for how many months?
Michael Sutherland, for a few months now, 2 or 3 months now.
Yeah, long while.
So we're very excited about that. We've done kind of a closed beta, and now we're opening that up a little bit, trying to flush out as many bugs or questions as possible before we dump that 1.0 on the entire world. But once that's out there, all you will need is an XBee radio built into your device, so maybe attached to something you made with an Arduino microcontroller, something as simple as that. And then you'll have a second XBee radio, and you'll plug that into something like this. This is a USB adapter for XBee. This one is made by a company called Parallax, a terrific company out of Rockland, California. And it just basically attaches your XBee radio to a USB cord. So you plug that second XBee into your computer, and your first XBee, and in fact hundreds of XBees in the same space, can access the internet simultaneously at that point.
Yeah, it's really cool to consider what you can do once you have all of these wireless things connected to the internet. One common question that we get from people is, well, I have all of these Wi-Fi devices. You know, why isn't the XBee Wi-Fi? Well, as it turns out, we actually have a Wi-Fi XBee, and you can find some information about it on the Digi website, and you can also find information about it on other sites like sparkfun.com, etc. But one thing that is interesting to note is, why ZigBee? Why would you stick to something like an XBee Series 1 radio speaking 802.15.4, or why would you use the meshing radio? Well, one common reason is power. The 802.15.4 radios and the Digi XBee Series 2 ZigBee radios use very, very little power. They're kind of like a camel in the desert. They can cross the Serengeti without falling over. And this can be used in some very, very interesting ways. As a matter of fact, just before this broadcast, we got off the telephone with an individual who wants to set up a massive building monitoring network for smells. And if you were going to do that sort of application and you wanted to find all the strange places that smells could emerge, you'd probably want that device to be small and portable and last for a year or two, or maybe even longer, on some batteries. And that sort of thing is really only possible using a low-power RF protocol.
Right, that's right. So the 802.15.4 and ZigBee are optimized for what's called low bandwidth, low power networking. And the idea of low bandwidth is not terribly low bandwidth, but it is with the expectation that this radio will be turned off or sleeping a lot of the time and maybe wake itself up periodically so as not to run its battery down. So it's not a high-powered device. Your cell phone is on all the time, and if you are lucky enough to have a smartphone, you know that your phone will last for about a day and that's it. Well, that's not going to be useful for a device that you want running for maybe years at a time. So you want to use a different protocol for that, one that's really sips at power and maybe isn't optimized at all. Choices aren't made about it so that it could stream videos, because you don't need to stream video to your toaster. However, you may want to monitor your toaster or your dishwasher or washing machine or your deep fryer and get little bits of information off of that. And so you want to use a protocol that's not going to waste a lot of energy and that is optimized and designed for being able to sleep and conserve power, so that the payoff is the battery lasts a long time and it becomes a practical monitoring device rather than one that maybe does some neat tricks, but you have to keep taking back to your computer and recharging every day. We wouldn't want to do that.
Yeah, I tell you, it gets addictive. I've got in my own house my air conditioner connected to my mobile phone, my garage door connected to my mobile phone, and then I have 2 zones of temperature monitoring. One that's used to tell if I should turn on the air conditioner before I get home, because of course I don't want it to be blazing hot. And then because I live in the state of Minnesota, in the winter, the big thing that everyone worries about in the frigid north is their basements freezing and the pipes bursting. That's the other thing. I'm also I'm considering building a automated sub pump monitor to detect or to prevent basement flooding. I'm actually sort of surprised that that doesn't exist already. If any of you out there are working on it, definitely let me know. Maybe we can collaborate. But one thing that's interesting is, so I have all of this stuff connected up to my product, which is the iDigi Device Cloud, and I use it for free, but I'm also the product owner. But you can use it for free as well. So if you want to get to connect to the crazy world of things, the Internet of Things, the Internet of anything, really, you can connect it up. Just go to www.idigi.com. What's cool about iDigi is once you've got something connected, once you have an XBee connected remotely, it's not just a one-way conversation. It's not a place where that module sends up information and what you get out of it is a little time series graph. You can actually send information down to that XBee module no matter where it is in the world, or a group of XBee modules. And that's a really powerful thing indeed. The first time you turn on or off your air conditioner, or on and off a Christmas tree or something like that, you have sort of this omnipotent sort of feeling that all of a sudden you've extended yourself and you're now controlling the world. It's pretty cool.
Right, and one of the most impressive things to me, or really the most useful thing about the iDigi infrastructure, is that it's massively scalable. So in other words, rather than, it's not that hard, and maybe a lot of people listening to this call say, well, I can write a web application that'll get information from an XBee radio or 7 of them and post that information online, and that's absolutely true. You can absolutely do that. You won't have any issues in doing that. So projects like that will work great. Maybe you use a gateway, maybe you use the XBee Internet Gateway for that and just post to your own server. The reason to go over, I think there are really, for me, 3 different reasons to go over to iDigi. 1 is you don't have to manage anything yourself. 2 is this massive scalability. So you can get on a platform and have hundreds of thousands of devices connected instead of just maybe topping out at 8 or 10 or 20 or 50 that you might be able to hook up with your own infrastructure and your own web server. And then the 3rd reason is really kind of command and control. Everything is built into iDigi so that you can actually get out over a network. From the comfort of your living room, manage devices, so manage gateways like this, that are plugged in different parts of the world, and get all the way in, reconfigure them, change their firmware, update their radios, put new Python programs in them, all from the comfort of your easy chair, which is pretty important if you are putting devices in remote locations, or even just into residences that aren't your own where you won't have any access. Beyond that, you can get from the gateway all the way out into the network of individual XBee. So if I have this installed, maybe I'm monitoring a cat feeder and a dog door, and those are in a residence, and let's say I've made a product and sold them into a residence, and I don't live there. I can actually get all the way out through iDigi and this gateway into the XBee itself and give it commands, update its firmware even, change its pin settings, do everything that I could do if it was plugged right into my own computer. And that's a really powerful thing, and it's pretty much indispensable once you get into larger size systems. It's not practical, even once you're out maybe in a residential situation. Once you're out into 4 or 5 or 6 different homes, or maybe you're an artist and you're sending your project away to a gallery. We have someone who does that. He just boxes everything up, sends it to the gallery, tells them to plug it in, and then he manages all the reconfiguration himself remotely. He doesn't have the wherewithal to fly out to a different gallery every time his art project is installed there, but he has full control, and that's a really wonderful feeling for a developer.
So we've been talking a little bit about different bits of Digi technology for a while. I'm curious to know what questions might actually be out there. I'm sure that there's lots of inquiring minds who want to know things about the crazy world of wireless.
Yes, we do have some questions, and people are asking their questions with the hashtag XBee Forum. So if you have one, you can go ahead and tweet that to us, or you can ask on Google Plus as well. Our first question is actually about Jordan's Make article. So Jordan, everyone would like to know a little bit more about your article. Remind us of the title and where they can find it.
Sure thing. So the article is Push Any Button from 25,000 miles. And it is in Make Volume 30, so you can find it, a reference to the article and where to pick up the magazine at magazine.com. What it teaches you how to do is very simply connect your garage door to your mobile phone. And it's a two-way conversation. So one particular use case, a very important use case is, oh my goodness, did I leave my garage door open? The second use case is, let's control that garage door and let's open and close it. And the way it works is very, very simple. There are 2 wires in just about everyone's garage door that goes to a button on the inside of the garage. And if you were to momentarily short those 2 buttons together, just do a little click, click like this, it's exactly what happens when your finger actually pushes the button momentarily. So our first task in completing that automation and what the article teaches you how to do is to use an XBee and a little bit of supporting hardware in order to achieve pushing that button. The next thing that we do is we actually connect that button up to a Connect Port gateway. Of course, you could use the beta version of the ZIG that we were mentioning earlier as well. And that completes a connection up to the iDigi device cloud where your mobile phone can speak indirectly through a little application to iDigi to sort of complete that whole circuit of control. And I happen to have over here, this is actually the supporting hardware. This is the permanent build version. And I put this up on my personal website. This is an open hardware design that you can actually order the board yourself. There's instructions for how to do that and where to get the board and where to get all the componentry, including the XBee and gateway. And what you do is you end up very simply connecting a sensor, a little magnetic sensor, to the connector here, and you end up connecting the button up here to this other connector, and more or less, voila, all of a sudden your garage door is connected to the internet. And I'll tell you something, it is a surefire way to impress your neighbors.
Great. We'll also be tweeting the link to the article and letting you know where you can find it online as well. We have another question from our friend Quinn, and he would like to know a little bit more about the technology behind the XBee Internet Gateway.
Oh, okay.
So I'll lead off, and then you can pick up maybe. The XBee Internet Gateway, so it was originally written in Python for the Connect port gateway hardware. It's still written in Python, and it's just that code has been expanded so that it can run not only on the Connect port, but on Windows, Macintosh, and Linux as well. It actually went through an interesting development process, which might be interesting to Quinn. Which is that it started off really as a prototype. So it was a very small program that did a very simple thing that worked fairly well and was very fast to write and very fast to deploy. And when people started using it, they liked it. It seemed very, it seemed like a great idea to have it. But like with any new program, it had some problems with it. You know, for example, didn't necessarily scale very well and didn't have a lot of features that people were interested in. But once we had gotten it out there as a prototype, it became much easier to say, hey, this is worth spending some time on. And so, and as a piece of open source software, it was something that not just I was the first person to write it, had to work on, but other people could. So some of my students at NYU wrote on it as well and contributed features and software.
Yeah, Ted Hayes in particular.
Ted Hayes in particular. And then after probably about a year of use at ITP and a couple other places it had gone by, I ended up wanting to include it in my book, and I realized that it needed to be made more robust as well. By that time, Jordan and I had become friends. We didn't work for the same company at that time. But Jordan actually came in and did sort of a ground-up rewrite to make it more resilient and scalable. So same features, same general design, but once we realized it was useful, we went kind of to a deployment phase. So we went from prototype to a pilot, and with success at each of those, we went ahead and actually decided, well, let's do a real release. And then from there, we've done more development. Most recently, two developers at Digi, Tom Collins and Michael Sutherland, and especially Michael, have been working on the software version that runs on laptop and other computers. So a lot of contributions, and that's really the joy of working with open source. But this iterative design process really paid off. I don't know that all those people would have been interested in a piece of software like this if it hadn't already been out in the world and proven its value along the way. And so for people who are making their own things, this really shows the value of making your own stuff, of starting out with a prototype. Whether you're you know, a individual engineer or you work for a big company or you're a maker in your own home, going through this process means that you're going to build better and more useful stuff, because at each stage of the way we learned what people wanted, what they wanted to use, and then we could build in that robustness and resilience as the project went forward.
Yes.
So hopefully that gives a little information.
Yeah, and speaking about digging into the technology a little bit more, when Rob was talking about the prototype phase of the Zig, one of the big hurdles to get over, which is a hurdle for a lot of people, is how do I get my program to do more than one thing at any time? And the essence of the XBee Internet Gateway is it's a Python program that on the behalf of an XBee, on the behalf of a user, the XBee Internet Gateway will actually go out and it will either send something up to iDigi or it will go and it will fetch a web page. In the original prototype version of the Zig, it really could only do one thing at a time, meaning that if you had 30 students using 30 XBees, student number one would sort of get to monopolize the XBee Internet Gateway until that web page was finished transmitting or sending information up to iDigi. And what myself and several subsequent developers helped a lot with was actually making it so that the program would run in tiny little slices. And so what would happen is the gateway would fetch a piece of a web page, and then it would move on to XBee user number 2, and then number 3, and then number 4. If you're curious to know what the name for being able to do something like that is, or a means of accomplishing it, it's called a reactor pattern. So if you actually look at the code for the XBee Internet Gateway, it's very core at the very center is a very lightweight thing that is able to multiplex I/O in a manner that's called a reactor pattern. Oh, actually, we should mention, before we move on, Quinn, who asked the question, we actually had the privilege of meeting in person.
That's right.
And one of his projects is on the XBee Project Gallery.
Yeah, that's right. Quinn's project, the gas hat, which is a hat with indicator lights on it, and a sensor module that I believe the sensor module goes in your back pocket, and it will warn those around you if there is a farting event, which is detected by a gas sensor and displayed on the hat. Quinn's very creative, and so while this was his kind of first major covered project, I doubt it will be the last.
Oh, I'm certain. And in that same vein, Quinn, remember that we just mentioned, we just got off the telephone with a guy who's setting up basically a smelling network in a building. So you're ahead of your time, but this stuff is already going commercial. It's going to be big. I'm sure you're going to have lots of big ideas that industries are going to follow. So thanks for asking the question.
I could see that getting integrated well with the bathroom monitoring.
I'm sure you're right. I'm sure you're
Occupied
right.
and, is it usable? Yeah.
And don't go there, yeah.
I'm sure you're right, Jared. Thanks.
So speaking of XBee uses, we have a question. What is the coolest or most interesting XBee use you have seen to date?
I think you got to do one, and then I'll do one.
I'll do one.
I almost want to go with some of the industrial ones. You want to pick one of those? We'll do.
Boy.
So, I mean, some of the ones that I think industrially are the most interesting are ones that are serving a purpose. Like basically, we make connectors that are used essentially in vending machines. And one of the things with vending machines, it could be something as simple as a bubble gum machine. These aren't exactly bubble gum machines, but we can think of them that way. Is that you put money in and you get gum out. And but the bubble gum machine presents a problem. Someone has to keep the bubble gum in the bubble gum machine. It can run out, and then when there's no bubble gum, you don't make any money. But there's also, it turns out, a secondary problem, which is that the people taking the money out of the bubble gum machine, maybe they're not you. Maybe they don't even work for your company. Maybe they're just someone at a hotel or a convenience store. And you want to make sure that for every nickel that goes into the bubble gum machine, you get a nickel out. And so actually monitoring those nickels in real time and monitoring the amount of bubble gum there, and maybe also monitoring the mechanism to make sure it's still running. If you could send someone out to check on that every day, that would be terrific, but it would be much too expensive. But if you can make a bubble gum machine that monitors how many pieces of bubble gum there are, whether the mechanism is spun, maybe whether people are walking by, you could do a little proximity sensor, and how much money is going in and how much money is being taken out. Well, then you can manage your cash flow. You can look for anything going wrong with the device, and you get the ability to deploy this huge network of machines in the world without actually losing control of them. So several of the industrial implementations, which I can't name by name, obviously, are essentially running on this model. And it's a model that I think is incredibly powerful. It could be for something like the dishwasher in your house, or you know, if it's out of supplies, that it could signal, or if there's a problem, it can signal for a repair. And this is something that people are talking about a lot right now. So what's your favorite of the creative projects that you've seen?
Oh, the creative ones. Well, before I answer that,
Okay.
I want to hear what Jared has to say. Jared, what's your favorite project?
You know, like Rob, I always like the industrial ones and really useful ones, but the ones that come to mind when somebody says, "What's your favorite?" or what's an example? I think of one that's rat traps. And so there's like a shoebox size electronic rat trap set around the building, and so when a rat gets or a mouse gets, I think it's mouse traps, probably not rat traps, but when a mouse gets stuck in there and it's caught, you don't have to just wait for it or have somebody come and check in on the inventory, right? See if there's mice in there, you know, every day or that kind of thing. It automatically sends a message from one to the other, or up to the system that can check it up to the internet. So I like that one.
Oh, that's yeah. The building the better mousetrap is definitely one of my favorite ones too, and it's one that people can readily identify, particularly if they've ever run across any of the critters before. Yeah. What is my favorite creative project? Yeah, there are so many. It's hard just to pick one.
All right, so I'll give one of mine, and this is really very XBee focused, but I thought it was just such an ingenious and delightful solution. So Daniel Liss, who is a designer, an interaction designer, has a daughter. She was a toddler at the time, and she got on a jag. She's maybe 2 years old, of always asking when Daddy was coming home. And because she was a toddler, she wouldn't just ask when Daddy was coming home. She would ask, when's Daddy coming home, 75 times an hour, much to the distress of his wife, who had to answer the question 75 times an hour. And so Dan, being a prototyper, decided that he could build something that would solve this problem. And so he decided he would make sort of an interactive sculpture that would detect his proximity. And he decided on a pair of old shoes, so a pair of old tennis shoes. And those old tennis shoes, he put a little actuator, servo motor in them, and so that they would, sitting up on the table by the door, when they detected that he was close by, they would walk a little. They would just back and forth walk a little. And as he got closer and closer, the signal strength, now he was wearing an XBee radio on his belt. He put it in a little like pager case with a battery. And as those transmissions got stronger and stronger, the shoes would walk faster and faster until they were almost running, and by the time they were running, the door would burst open and Daddy was home, and she loved it. So she had this whole interaction that would happen for her. And I just think that's one of the most charming and interesting ways to replace a cable with an XBee radio. So that's one of my favorites.
Oh yeah, that's great. I'm going to go a slightly different angle. There have been all of these autonomous vehicles recently, and they just, it's almost like watching evolution in high speed. I mean, you just see these things progress and get more and more complex. There's a website out there. What's the name of the big collection of the autonomous vehicle people, the flying machines guys?
Oh,
the
so
quadricopters.
Yeah, so this is sort of a DIY site for UAV.
Yes.
For unmanned aerial vehicles, and that includes things like quadcopters, these helicopters with 4 blades on them.
Traditional planes too.
Traditional planes,
Yeah.
And there's also a lot of people doing work with high altitude aerial balloons. So these kind of like big weather balloons that are being that you can release and can go up to I think maybe 80,000 or 100,000 feet. The area where you can start to see the darkness of space and the curvature of the Earth and stream data back from them.
Yeah. What was really neat, what caught my attention about some of these recently is people have created this software that runs on a laptop, and you can connect an XBee to the laptop, where you can actually draw in 3D the route that you want the vehicle to take, and then you launch the vehicle, and it actually follows the route. And why we don't have those at Digi headquarters or in Digi Utah, I have no idea. I think we have to get it to you.
Yep, we've definitely got to do some shopping. Actually, speaking of weather balloons, there's one more really terrific project that I think we should point out. So the 2012 Olympics are being held in London, and one of the governments and the community's concerns is that people not just show up at the Olympics, but they actually go out and see something of the United Kingdom, see some of the fantastic sites and historic monuments that are out there. And one of the projects that's being put together is a art project that's going to be happening at the end of August at Hadrian's Wall. And Hadrian's Wall is basically the same idea as the Great Wall of China. It's a little shorter, but it serves the same purpose. So right around the year 122 AD, the Romans decided that they would build a wall to separate England, which they occupied, from Scotland, which they were having great trouble occupying. And so they decided that really they didn't want the northern extent of the Roman Empire to be the entire British Isles, that Scotland could remain outside, and they would just build a wall, and there they would stop. So it was a barrier. Now it's actually an attraction, so people can go out, and Hadrian's Wall crosses the entire island. It's about 100 miles long. So a group of artists that call themselves Yes, Yes, No, most importantly Momo Kuo and Zach Lieberman, are putting in an installation of weather balloons. Now these balloons won't be going up to 100,000 feet. They're going to be about maybe 30 feet over the wall, maybe even less than that. And they're going to have colored lights in them. And the idea is that you can send text messages, and they're looking for text messages that are on the subject of both borders as separators, but also borders as places where things now also come together. And those text messages will be streamed out to the balloons, and the balloons are going to react with different colors of light based on users' input. It's going to be running for a few days at the end of August. It is a great implementation of the actually a variety of Digi products. So the radios in the side of the balloons are going to be XBees. Those are going to be anchored together with some connect port gateways that use cellular connections to actually get the balloons online. And then the whole thing tied together with iDigi. And the reason for iDigi, and it's so important, is this thing actually has to be deployed. It's going to be deployed by hundreds of individual volunteers who will have to set these things up. No one will be able to see the whole implementation at the same time, so it has to be remotely controlled. And so the plan is to control, monitor, and actually run it through this central cloud solution, this device management solution. We're working on helping them put it together right now, and we're actually very excited about it. It's, to me, this perfect blending of an industrial-sized implementation with some of the things that personally I care a lot about, reaching out to humans, kind of celebrations of the human spirit. And you know, the Olympics is a terrific event, and this is being put together by a group called London Festival that is in turn associated with the Olympics, but also trying to make the Olympic event really pay off for the rest of the country in a beautiful way.
They're using the XBee programmable, aren't they?
Oh, they are, yeah. That's correct. You want to say a little about, or maybe you or Jared want to say something about it?
Many people don't know. Well, I'll lead off, Jared. Maybe you'll add something. But a lot of people actually don't know that the XBee Zigbee actually comes in a programmable variant where you can actually change the behavior of the XBee. You can load your own code right on the XBee. So if many of you are experimenting with microcontrollers today, either you have an Arduino or a BeagleBone or a Raspberry Pi or something like that, and you've discovered the joy of embedded programming, well, it turns out that there's a low-power XBee module that has all the fun benefits of being able to run on battery power for a really long time, but you can actually put your own code on there and change the behavior of the XBee. Maybe you're going to control lights like Zach and Momo are, or maybe you want to read from some sophisticated sensors or reverse engineer your car and make it wireless. I don't know what you're going to do, but you can do that with the XBee programmable. Anything that you want to add to that, Jared?
One of we took the scariness out of embedded programming on an RF module. So the things you worry about on an RF module are, am I going to mess up the RF performance, and am I going to mess up the certifications you guys paid, tens or $100,000 of dollars getting? So we've taken that out. So you keep the certs in place, you keep the performance as is. We've just blocked off a section of code that you can play with, your own little sandbox, and there you go. It's your programmable XBee.
That's great. There was one other thing I wanted to mention that actually when you, Rob, were talking about the high altitude, the ultra high altitude balloons that we've been seeing a lot of.
Yeah.
A lot of people also don't know another sort of only partially discovered Digi product is the 9 Extend radio. And so a lot of people I see, they've been building balloons with a traditional XBee, and an XBee S2B will go, what is it, Jared, is it 1.6 kilometers or about 1.8 kilometers? 1.6?
Yep, somewhere in there, yep.
Somewhere in there with the proper antenna. Well, a lot of people, they want to go up, they want to try and hit space, right? Well, we actually have a radio that requires a lot more power, but it is within the federal, the FCC system, so that you don't actually have to have a license to operate it. It uses 1 watt of transmit power. And Jared, what's the furthest that you've actually tested the 9 Extend radio, and how did you do that test?
It was one of our customers tested it, and they hooked it up to an amateur rocket competition, and they reached what's considered near space. I think it's 80 miles, and
wow.
That's this radio right here, actually. So
that's cool.
Wow, 80 miles that radio. Now, granted, you need line of sight, which is not difficult if you're going into space. It's not necessarily going to reach 80 miles on the ground. This is true of any
exactly.
radio system, not unique to that. But that gives you a good idea of some of the performance that's available out of a very small package. So that's a really exciting project. Do you want to hit us with another question there?
Yep, we're going to do a couple more questions, and next we're going to take one from our friends over at Toy Makers. And this is a question that they get pretty often, and it's, what are the applications of mesh networks? What have you seen, and how easy would a mesh network be for a newbie to set up?
We're going to have Jordan take this one.
Great. So first of all, what is a mesh network? In the absolute simplest terms, a mesh network is a self-healing, self-forming network, generally of 3 or more radios. And I say 3 because if you only had 2 and they could talk to each other, that's just a simple point-to-point link. If you have 3 radios that are all sort of in a line, which is one way of thinking about the topology of a network, and all of a sudden you move the 2 outer radios apart to where they can't talk to each other anymore, if you introduce a radio directly in the center, the network will automatically heal itself, and all the radios can talk together. One such meshing protocol is known as XBee, which is a standard that multiple manufacturers make parts for. Digi makes the XBee Series 2 module that can talk to the XBee standard. Generally, the applications for mesh networks have to deal really with wanting to cover a lot of ground, be able to speak further than you can normally speak, or be able to route a signal around some difficult circumstances. And we see in the commercial and industrial world things where you have installers who don't know anything about radios. They just know that they've been asked to install a sensor someplace or be able to detect something, and they just sort of roll them out and they kind of ad hoc distribute them, and everyone can be confident that the network is going to work because the radios sort of self-discover each other and figure it all out. We see a lot of people experimenting with mesh networks. As a matter of fact, that art project from Yes Yes No is actually a mesh network where they're going to be controlling these lights, and lighting control commercially is a really big application for mesh networks. If you recall what Rob had said, they're going to put in a cellular connect port, a connect port X4 gateway. There's only one of those, And the radios are going to go out that are installed in the lights along the wall, and they're going to stretch a very long distance. Well, the gateway actually can't reach. The radio and the gateway can't reach the nodes that are at the end of the wall, and the signal actually has to route through all of the balloons. And those sorts of circumstances where you're trying to extend the range is a very typical arrangement for a mesh network. There are other alternatives, other mesh networking protocols and schemes out there that have some advantages and disadvantages. And actually, I'll ask Rob, could you sort of explain simply what's the difference between Digi's proprietary mesh networking standard, DigiMesh, and the XBee mesh?
Well, in simple terms, they have different features to them. And so depending upon your individual application, one is going to be more appropriate than the other. So XBee, which is a cross-manufacturer open standard for mesh networking, has, well, the first feature is that it's cross-manufacturer. So our XBee radios, the Digi-XBee radios, the XBee XBee radio, will talk to XBee radios from other manufacturers. And so you can have this heterogeneous network of all different manufacturers communicating together. Now, the XBee standard, as it's put in place, also has certain limitations. It intends for some of the radios in the network to be on all the time. So it intends for there kind of, in broad strokes, for there to be base stations along the way for the most robust network. The DigiMesh protocol doesn't require that, but there's a downside to not requiring that, which is that you have to keep the timing between the radios so they all fall asleep and wake up at the same time. And in some situations, you're going to lose that timing, and so you want to make sure that you have multiple pathways in the network. DigiMesh is typically better for a dense network. XBee is going to perform better in a somewhat looser network where you have fewer radios. But they're both useful protocols, and our radios can be, certain models can be firmware upgraded so they'll do one or the other. DigiMesh runs with the 802.15.4 radios, and then XBee runs on what Jared was describing as the Series 2 hardware. But they're all pin compatible with each other, so if you've made a decision to go with one on the prototype type of network or a pilot network, and you decide, well, I want to, I'd actually be better off doing the other one, you won't have to rebuild all your devices. You can just pull the radios off and push the other ones in.
Yeah, one of the cool things also about DigiMesh is that it runs on a bunch of different radio module types, particularly a lot of Digi's long-distance modules. Jerry, can you share the other places where you can, the other Digi radios that can operate with DigiMesh?
Yeah, there's the Extend, actually. You mentioned that long-range Extend radio. We have a DigiMesh version of it. So now you can go 80 miles times however many modules you have if you're going through space. But we've got several different XBees. The XBee DigiMesh 900, so we'll talk at 900 megahertz. We've got an 868 called the XBee 868 LP, and it's a low-power 868 megahertz module, and it does some frequency agility things that are really cool, and that's intended for Europe and some other regions. Those are some that I mentioned. I did want to correct one thing from Rob. He was mentioning that when you have sleeping routers in DigiMesh, they are all time synchronized, and he had a concern about them getting out of sync. It's true that the clocks on these are not perfect. They have a certain amount of tolerance, right? And so what we do is if a module becomes unsynchronized, it will broaden its wake-up time a little more and a little more to the extent to where we know the maximum that the clocks can drift, and they always make it back on.
Right, yeah, so your network will come back together. That's exactly right. But in your network design, you are better served by having a denser type of network, because if clock drift does happen, it does take some time for that to come back together and for the network to heal. And so you'll end up having a more resilient network. So this is just one of the concerns that we might have. You want to make sure you're getting the benefits out of DigiMesh, the ability for all the radios in the network to sleep. If your entire network is plugged in all the time because you have mains power, then maybe that wouldn't be a concern. We have been asked, I think, to wrap it up. So I wanted to say a couple other things. I mentioned the gallery site, which is gallery.digi.com. That's where you can see some really interesting projects that people have done with XBee radios. It's a lot of fun. We've got videos and links to learn more about all the different kind of creative projects. We're also about to launch a new site that will have examples of how to build different things with XBee radio. So step-by-step instructions, and they're intended to be modular. We're just getting that started right now, but it is up and kind of in a very quiet beta, and that's going to be at examples.digi.com. So that might be worth checking out. In probably about the next week, we're going to have a more formal announcement, and there'll be a little more stuff on that site. If you're interested in learning more about the XBees, as I think was mentioned at the beginning, there is a lovely book written by me called Building Wireless Sensor Networks. That's available online. You can go find it at Amazon or wherever else, and it's got tons of information about how anyone can make projects with the XBee radio. If you happen to speak Japanese, it's also been translated into Japanese. And if you're interested in the iDigi device cloud solution, that's an easy one to find. It's idigi.com, and you can find out more there and sign up for an account.
Right, and obviously many of you probably already follow us at Google+, but we have an excellent blog written by Liz Preston where you can actually see all of these announcements. You can get a recap of all the links and all the information that we've shared today, and that's at www.idigi.com/blog.
Yep, so we'd like to thank everyone for joining us. We appreciate your time today. You can also find a recording of this Google On Air on our blog. We'll be posting it later today. And if we didn't get to your questions, we'll answer them either on Twitter or in a blog post coming soon. All right, thanks everyone.
Thanks, bye.
Thanks, bye-bye.